Hello everyone. Today we are going to discuss about mass and weight. So mass and weight are almost same things, but sometimes students are confused about this. So what is the difference between mass and weight? Remember this thing that usually this is a common mistake that whenever if you will ask from someone what is your mass, sorry, what is your weight, they will tell you that my weight is 65 kg or 40 kg, whatever. But remember this thing when we are saying kg, so we are wrong. This is not weight, remember, because unit of weight is Newton, not mass. So there is a small difference between mass and weight. So today I'm going to tell you in detail that what is the difference between mass and weight and how we can calculate weight. Okay, let's start now. First of all, mass. So remember this thing that matter is anything that has mass and takes up space. So first of all, you should know that all the object, all the substances are made up of matter. And first you should know what is matter. So matter is basically anything which occupies space, having mass, having weight, that is matter. So then we can say that mass is amount of matter in an object. How much matter is there in any object, that is mass of that object. Okay. So the mass of an object is measure of the amount of matter it contains. So whatever the amount of matter is, that is the mass of that object. And the unit of mass is kilograms. So we can measure the mass in kilograms, as well as there are many other units, grams also, milligrams, etc. But the basic SI unit of mass is kilogram. So for example, see if you have two masses, okay, you want to compare them. So there is a balance now. Basically, we are using balance to compare the two masses of two objects or to measure the mass. So see how you will compare. See, you can see that there are two different parts of this balance. So you will hang the mass on one side, okay, so it will fall down. So you will put another mass on the other side. So when both side masses are equal, you will see that balance is straight line, will be straight lines, arm will be straight line. So it means that both masses are equal. Okay, so just we can say that I will read from here that for two objects of the same mass, the arm of the balance would be level. If you are saying that both sides are equal, so arm will be level. For two objects of different mass, the end of the arm supporting the heavier on one would drop and the other end would rise. Means that if one is heavier than the other, so of course one side will move down, other will go up. And the mass of an object can be found by placing it on one of a balance pan and placing standard noun C on the one side. For example, it is written over there, this is 5 kg box. So you will put over there some mass. So when this arm is equal, it means this is 5 kg. So in shortcut, we can measure the mass by using a balance. And unit of mass is kilogram. So now this is important. What is weight? See, weight is a force. Okay, it is a force with which earth attracts a body or pull a body towards the center. This is basically weight. Okay, so when we just how someone can ask that how we can calculate the mass, how we may weight, how we can measure the weight. So remember, simple, just we will multiply mass with gravity, means 10, that is equal to weight, because gravitational acceleration, gravity is the pull of the earth. So as I told you, weight is basically the force with which earth attract any object towards the center. Okay, so I will read from here. You can see the weight of an object depends on its mass. This is because weight is due to downward pull of the Earth's gravity on the object, and the force of gravity on an object depends on its mass. So remember this thing: greater the mass of an object, greater its weight. As weight is a force, so its unit will be Newton. So just when I told you that greater the mass, greater the weight, it means less the mass, less will be the weight. So weight depends upon the mass, but remember it also depends upon the gravity. If gravitational pull is less, so weight will be less. I will give you the example. Before going to that example, just let me complete this, then I will solve some questions for you. See now, gravitational acceleration is basically also known as gravity, and its value is 10 meter per second square. It is also known as gravitational field strength. Also, you can write its unit as 10 Newton per kg. And gravitational field strength is the force experienced by a mass due to gravitational attraction. And weight is the term we use for the Earth's gravitational force on an object. Let's see now. Say this is an object, its weight is downward. So if you want to calculate what is its weight, if you have the value of mass, you will just multiply by 10. The formula for the weight is now mass times gravity. So you can see W equals to mg. M is mass, and you will multiply with gravity, you will get its weight. So you can see its mass is 1000, so 1000 times 10, it is 10,000 Newton is the weight of this animal. So this is a very important thing. Remember that mass does not change. It's the gravitational force that may change. So for example, this is any animal, its mass is 1000 kg, so it will remain 1000 kg unless if you will not eat something, so that is different thing. But at the same time, if you will measure its weight mass in one part of the world or other, or one planet to another planet, mass is same, but weight will change. Why? Because the weight depends upon the gravity also. So gravity of the earth is 10, so of course weight is 10 times 1000. But if you will go to the moon, gravity will change because gravity of the moon is only 1.6. Okay, so that's why weight will change. You can see now. So same animal, when we bring it here on moon, so its weight is 1600 Newton. But its weight on the earth is 10,000 Newton. Why? Because on earth gravity is 10, so 10 times 1000 is 10,000, but on moon gravity is 1.6, so 1.6 times 1000 is 1600 Newton. So it means we can say that weight also depends upon the gravity. And see, one interesting thing here, in space its weight is 0, because in space objects are flying, there is no gravity, so there will be no weight, because when g is 0, so 1000 multiplied by 0 is 0. I hope it is clear now. Just you can see this is an object, mass is 500 kg, so 6000 Newton upward force from the rocket engine, so weight is downward. What is acceleration of the rocket? So how you can calculate the acceleration of the rocket? You know that W is equal to mg. So what will be its weight now? This weight is 500 kg mass times gravity, it is 5000 Newton. Okay, this is the weight of the object, its rocket. So what is the resultant force? See now, upward force is 6000, downward is now 5000. You just subtract them, so it is 1000 Newton. So the resultant force is, what is force? Force is mass times gravity. This is acceleration also. So acceleration is basically gravity, gravitational acceleration when it is moving upward. So 1000 is equal to 500 times a. So you can rearrange a equals to 1000 by 500. That is 2 meter per second square. This is the acceleration of this rocket in upward direction. So this is now final. Now conclusion that what is the difference between mass and weight? Simple. You should know that mass depends on matter, whereas weight depends on gravity. First thing. Mass remains unchanged, it never change. But weight depends on gravity. It may be changed. If you will go to the moon, weight will be less. Okay. Whereas mass is measured in kilogram and weight is measured in Newton. So these are, you can see that, three main differences. So one more thing you can add, that weight can be measured by calculated by using formula W equals to mg. I hope it is clear now. Just simple, for review I will tell you that weight, this is formula for the weight, W equals to mg. Okay, now if, see, an object having a mass of 50 kg, so what will be its weight? Simple, you will write 50 times 10. Why 10? Because gravity is 10 meter per second square. So 50 times 10, 500 Newton. But same person, if will go on moon, so gravity of the moon is 1.6 meter per second square. So the weight of this person on moon will be 50 times 1.6. Let me check what is answer. 80 Newton. See now, weight reduces only 80 Newton when this person will be on. Mass is amount of substance. Okay, this is the main difference. And weight depends upon the gravity. Mass remains same everywhere, whereas weight will not remain same everywhere. I hope it is clear now. So thank you very much. See you inshallah in the next class. Take care. Bye bye.